Good evening and a very warm welcome to this special event, one of many taking place as part of Soil Health Week 2025, which is running from the 22nd to the 26th of September. And we're delighted to present our webinar, Digging into Soil Health, Ask the Expert, where you will have the opportunity to engage directly with leading specialists in the field. And we're going just to remind everybody, we are recording this evening's session, and please remember to submit your questions in the Q&A tab as we go along. I'm sure you're going to have lots of questions. You have a great opportunity this evening to ask the very best in the field. So we're very lucky to be joined by what I describe as the A-team of soil health this evening. But before I introduce our expert panel, I'd like to welcome Teagasc researcher and soil microbiologist, Dr. Fiona Brennan. Good evening, Fiona.
Hi, Cathal. Thanks very much, and welcome everyone.
Yeah, how are you keeping this evening?
Great, great. Always a good evening when you're talking about soils.
Yeah, Fiona, you instigated this, so we might start off maybe. Can you start by telling us maybe what does the term soil health mean, and maybe why is it so important?
So soil health is basically the condition of soil, and in soil we need to consider the biological, physical and chemical health of soil or condition of soil. And all of these enable soil to deliver certain functions. So just like, as I say, for ourselves, if we're healthy, we're able to do a lot of things. And the same is true for soil. But in the context of soil, we're thinking about functions like producing food, storing carbon in soils, regulating climate, storing and filtering water, a home for biodiversity, nutrient cycling, these whole range of really essential functions, and that's what we consider soil health. So essentially, a healthy soil is a functioning soil.
And I see you have a symbol, Ground Truth, written behind you. What's that all about?
So Ground Truth is a citizen science project we're running this year on soil health, where we have citizens all over the country doing some simple tests on their soils. So it is funded by Research Ireland and the Department of Education. And part of the activities for this project was to have this dedicated Soil Health Week and to get the country talking about soil. So that's part of what tonight is about. Get some events that everybody can attend, no matter what your level of soil expertise is, and ask whatever questions you have. And we have a panel to try and deal with them as best we can.
Yeah, and look, every time we do something on soil, there's huge interest and there's always a million questions and we never have time to answer them all. So I think it was decided to have the panel of experts that throw in their questions and we'll answer them here tonight. And lots of questions have come in already through the registration. And if you have questions tonight, there's a Q&A tab, so throw them in there as you think. So we might introduce our panel to kick us off. So what I'm going to do is I'm going to call out the panel names and they'll do a brief introduction themselves to let you know what their specialist areas. Okay, so first, so Fiona, you're introduced already, so you're off the hook. But we'll go to Rob Coleman first.
Thanks, Cathal, and thanks a million, Teagasc, for having us along. It's great to see soil health getting the spotlight. My name's Rob Coleman. I'm a farmer in North Cork. I'm the chairman of Base Ireland, which is a discussion group and a soil health sort of, I guess you'd say, organisation. I have mostly crops on the farm here: wheat, oats, barley, rapeseed, beans, and we have some cattle and sheep as well. I farm with my father Billy. I learned a lot of my soil information and my love of soil from him. And I suppose I'm very aware of the fact that our audience may be a very diverse group. So if you have an interest in soil, if you love soil, it doesn't matter if you're a gardener or an horticulture or you're a farmer. I think it's great to sort of swap ideas and take any piece of information and apply it to your own situation, your own context. So I'm looking forward to it, and thanks for having me.
Thanks, Rob. Olaf Schmidt, maybe Olaf, you're next.
Thank you very much, and good evening, everybody. It's really nice to be here. I'm here in UCD in Belfield, and I'm a soil ecologist mostly, and like the others, I love speaking about soil, in particular about earthworms, because they are really useful and also easy to study. So I really look forward to this and to interacting with you all. Okay, thanks so much.
And Dermot Forristal.
Yeah, thanks, Cathal. Yeah, I'm Dermot Forristal. I was formerly a crops and researcher with Teagasc, just recently retired. I'm here, I suppose, because I have a bit of expertise, I suppose, in machinery, compaction, that sort of area, and also crop establishment systems.
Lovely. And Veronica Nyhan.
Thanks, Cathal. Veronica Nyhan, based out of Teagasc Oak Park. I am the Teagasc soil and plant nutrition specialist. And my background probably comes more on the tillage side of the house. I'm looking forward to the questions that are coming and to listening to my panelists also and learning a bit myself.
Excellent. And Saorla Kavanagh.
Thanks, Cathal. I'm an ecologist working on farmland biodiversity in Teagasc, Johnstown, Castle. So my expertise is in pollinators, which some of them live in the soil.
Super. And last one, David Wall.
Hi, Paul. Hi, all. I'm a soil scientist by trade. I work in Johnstown Castle, where we're doing all things soil, I suppose. Specifically, my area of expertise would be soil nutrients, soil fertility, if you want, also carbon and linking soil processes. So, to function as Fiona has said. So, looking forward to this and looking forward to, I suppose, the questions coming in.
Super. And just to round off, my own name is Cathal Summers, and I'm a water quality specialist Teagasc, and I have the look of getting all the questions to our panelists tonight. So, as you can see, we have a huge range of experience here, from to the field all the way into the labs. So, throw in those questions as quick as you can. Just to kick off, though, Rob, we might get going with you, and I think you started really, really well. You're involved in the practical application on the farm. It's all well and good coming up with all these ideas in the labs, but it has to work in the field. But just to kick off, maybe, why is you're obviously doing a lot in soil health, but why is it important to you, or where did that come from?
It certainly came from my dad, Billy. I know that a long time ago in the 90s, our local Teagasc man, Kieran Collins, would tell me stories of dad handing him a spade and getting him to dig the soil. So that was my upbringing, and I think we can be farmers nowadays, and I'll answer from a farming point of view. And it probably is the same for anybody working in the soil. We stand on top of it and we look at it, and we drive gear on top of it. But really, to get into the soil and to look at the soil, it sort of excited my enthusiasm and my imagination for soil. This topic, you can go as deep as you want on it. It is endless. And some people like certain aspects of it, biology, some people like the physical side of it, the chemical side of it is heavily studied in industry. And there's something there for everybody. I have friends in Base Ireland who've got microscopes who like that side of thing. Not really for me, but I know it's there and I trust it, and I have a passing interest in that. So here on the farm, it's important for a lot of reasons. We can only scratch the surface now this evening, but if I was to say that, it is the foundation of our business. We often, as farmers, can get distracted by machinery and animals and sheds and all the things that day to day we work with. But actually, if you look after that soil, everything else is built on top of it. So what we have done here over time is try to just have a focus in every single decision on the farm to allow for what is this doing to our soil health. And if you can nurture that, it will look after you. It'll look after you financially, and it'll look after you environmentally as well. It's funny that those two things are very closely linked. If you are careful with nutrients, and if you have a real healthy functioning soil, it'll become more efficient in the way it holds on to nutrients. We want the nutrient we use in the land and in the plants, and a whole way up the food chain. We don't want to lose that. And if you're wasteful with it, it's bad environmentally, but it's also bad financially. So we'd be talking on this farm all the time about soil health, and we'd be doing it in an awful compromised way, because we've great plans every year and then it starts pouring rain and we have to compromise, and we've great plans for no tilling crops with no tillage in the right place, and next thing the autumn comes really difficult and we change, and we have to have a very practical approach with an awful lot of, I think, foundations in what we learn from the people here and from the internet and our peer-to-peer learning groups, and then we have to sort of try and stew that down into something that you can actually do when you walk out the door. So I would say that it's important to me, first because I love it and I have an enthusiasm for it, and I kind of passionate about the subject, but secondly because it really puts the bread on the table here. And I think over time, this will come more and more to the fore, and it's great to see an event like this, and it's great to see all the people sort of tuning in to learn more about it.
I'm delighted to hear that you're getting a spade in your hand, because I'd be always getting on to farmers to say the bigger the tractors getting, the further away they're getting from the ground, and the spades, they nearly want a user guide on how to use them these days sometimes. So I suppose just going back to the basics, like what would have been one of the biggest changes that you made on the farm? Maybe not biggest change, but most effective, that enhanced your soil health?
So we start back with exactly what you said and what Billy taught me was that, if you can dig and look and observe, because it doesn't matter how much you know or how clever you are, if you can't look and take in what you're seeing, he brought my attention to that. And he was in a field one day plowing it, the 33-acre field, and it was plowing up so nice and so lovely. And he thought to himself, why am I doing this? This soil doesn't actually need to be plowed. And from there, from that turning point, we started to get away from plowing and we started using minimum tillage systems. And I think over the course of time, that looking at tillage in isolation as to what cultivator you have, what drill you have, I think that has broadened into all the other pieces that have to go around this. So we can't really talk about the physical nature of soil in isolation anymore because it links across to the biological nature of soil and to the chemical nature of soil as well. So what we started doing was we started reducing our tillage. My dad chopped an awful lot of straw here in the 90s. So I think we definitely benefit from all that organic matter. And once I joined Base Ireland, then in sort of, nearly 10 years ago now, started building on top of the foundations of what I'd already learnt. That always believed in an awful lot of organic manures to try and get away from that bag fertilizer, which is soluble by nature. And also it's simply what it has in the bag is all it has. Whereas organic manures bring an awful lot more to the situation. And I think over the course of time, we dropped the P and K on the farm completely from the bag, which was a huge cost saving, but also environmental benefit. And then from there, I tried to bring in some of the cover cropping elements. I tried to change the rotation so that we were always giving the soil a chance to recover after we tried to make money. So I would say there would be a cereal to make money, and then there would be something to build it back up, like a cover crop or a break crop. So we go backwards and forwards between the two. And I started composting the organic manures as well, which I felt was bringing more biology to the situation. The raw nutrient was good, but I felt like we could do better, and that has been quite successful. And then from there, we started doing some clever things that would be further along with adding carbon sources to our nitrogen, because we need nitrogen to grow crops. And I think it's fine as long as you use it carefully and responsibly. So we try to buffer that, because I think it has a negative impact if you use too much of it, or if you use it kind of without thinking too much, or even at the wrong time of the year. Getting a lot of those basics right first and foremost. Our drainage would be a massive one, and it often gets overlooked. It's so fundamental. If your drainage is wrong, it's very hard to fix it with any other the clever things that I've been mentioning. And from there, look, we dropped the aphicide on all our crops. We don't use aphicide in this farm now for a few years. We still have it just in case there's a bad situation comes along. We don't have the luxury of forgetting about our income. But what that has done, I think, is it's helped our soil biology. It's helped the beetles in the land, which I think is helping our slug issues. And then that's the bottom of the food chain for everything else. So we would have seen bird populations evolve a little bit, and we would have seen sort of positive changes in the color of the soil and the structure. There's a sort of a little scratch at the surface of what's been going on in Castlemagnor, more or less.
A lot going on there, and you mentioned loads of practices and a lot of science behind that, and we might dig into that a little bit, pardon the pun. But Olaf, Rob mentioned the use of organic fertilizers, so slurry, farmer manure, that kind of stuff. There's a perception out there that maybe if you were putting on maybe too much slurry, that it has a negative effect on earthworms. Can you comment on that maybe?
Yeah, thank you very much, and also thank you, Rob, for this introduction. That was a really nice overview. I think earthworms are just so cool, because what you were saying, you can see them. I mean, I love them because for education, for farmers, for policymakers, look at the things you can observe. You see their structures. And all the things that you just mentioned, they affect, nutrient structure, drainage, food for wildlife. You have mentioned it all, and we all know them. So yes, absolutely. If I'm at the plowing and in open days, I'm always asked, what's the impact of slurry, which is of course based on observation. So in the last years we did with Johnstown Castle a PhD study, and we looked at what's the effect of slurries and also the different application methods. And it is true, in particular with a splash plate, a small number of earthworms are expelled. Why is that? Because there is ammonia in the liquid, in the slurry, which infiltrates, it hits their skin, they escape upwards, and when they have left their channels, really they are exposed to UV light and also the birds, and they die. Now on average we found something like 2 worms in a meter square were expelled in different systems, in a total population of about 250 in a meter square. Okay, so I just have the chapter here. the students. So it's, 1% or so are expelled. That is, absolutely true. But in the long term, so we have looked at, the different treatments with mineral fertilizers and with splash spread and trailing shoe. And the main effect is actually if you use any fertilizers or slurry or none. So the lowest population are in 0 in the control, which is a little bit, what you wouldn't expect. But this is because they love, productivity, they love food, they love input. So the short answer is yes, a small number are expelled, but in the long run, it's not, negatively, impacting on the earthworm populations.
So it's probably a lot down to maybe not putting too much slurry out at one time is probably one of the key things, as you suggested.
Yeah. Although in this work, we haven't looked at the load, which would normally be restricted anyway by the infiltration and hydrological load of the site, so you wouldn't use that anyway.
Yeah. Just jumping subject a little bit to New Zealand flatworm, Olaf. That's a question we've gone in. Is that an issue in Ireland?
Yeah. So you have all the negative questions here for me.
Yeah.
Invasive species, of course, are really important. They are one aspect, of global change. Absolutely. We have all these species which, inadvertently, or they were introduced, on purpose. We know the New Zealand species, which is a large brown species, has been here since at least we know since 1963, in Northern Ireland in particular, and also in Scotland. It is in the Republic, it's everywhere. If you look at the maps, the distribution is in all corners of the country, which indicates clearly it's moved with us people. It was mainly used with horticulture. The eggs are very hardy. They look like black beans. So we know they are here. Are they harmful? There's one study that was, in AFBI in Northern Ireland, where over a long time they actually introduced them, into plots, and they found that they, in particular, reduced the abundance of the dewworm, or the large common earthworm, Lampicus terrestris, which is a very important species because it makes these big channels. So they are earthworm hunters, and they will eat them. The jury, to be honest, is still out. Overall, I have a sense they have been now here for so long, they will now just be part of the food web. And we know that even a new predator will never exterminate prey because of ecological waves and things. So it's not a good thing, but overall I think the jury is still out. What is a little bit worrying, it has certainly moved from more urban settings and gardens and horticulture into farms, and we've seen it now in open fields, and so we need to keep an eye on it.
Yeah, and we will come back to you again on it, Olaf, because I know you have lots of good things to say about earthworms as well, so we'll come back on that. But Fiona, just to bring you in there, so Olaf's talked about there's a lot of things live in our soil, some bad, some good, but how would you know if you have a good biological activity in your soil?
So I think back to what Rob said, looking is one of the most useful things you can do. In your farming system, or in your garden, if you have farmyard manure going out, or slurry going out, or cow pats going out, or plant remains of plants going out, how quickly are they being broken down? That's a really good indicator. Is your soil active? You can do tests like, for example, in the Ground Truth, people have been doing the Undoer decomposition test. So it's a measure of soil function. But looking with your eyes and seeing what you can see when you dig some soil up, can you see little organisms going around? So earthworms are the most obvious, but can you see beetles? Can you see ants? Can you see life? And what's the soil structure like? Because we know, for example, that the microorganisms in soil, if they're active, you can get some really good soil structure because of the polysaccharides that they release. So having a look with your eyes is probably one of the most useful things. They can look at things like activity, so people would look at maybe enzymatic assays or respiration. They can give you an idea of some function, but I still think going out with a spade and looking you get as much information back. The other thing, I suppose, with activity is it's very much impacted by the environmental conditions. So down our part of the country, of course, Cathal, you know, we've had a really dry summer, really dry spring. So everything has really ground to a halt. And it's not necessarily that soil is in bad health, it's just been impacted by drought. And the same is true, you see a slowdown when you get a reduction in temperatures. So around the winter time, some of those processes would wind down and then hopefully take up when the temperature rises in spring. So they will be the main things that would impact microbial activity, or how you'd look and see how active the soil biology is.
Yeah, and Rob mentioned several really good management practices to improve soil health on your farm. I suppose the word AMF is going around a little bit. Can you tell us what is AMF?
So AMF is arbuscular mycorrhiza fungi, and they're fungi that form a partnership with plants, whereby they can be, I suppose, they're really effective scavengers of nutrients, things like phosphorus. They're also good at water, and they can supply these things to plants in exchange for some carbon and for some niche. So they're obligate biotrophs, so they have to be in association with the plant. So they get, I suppose, going back to when plants first evolved, they had no roots. So the fungi were their roots. And now obviously plants have evolved roots, but these fungi are still really important in terms of the overall functioning and health of soil. So some plants are more likely to form those symbiotic relationships than others, and they're very much impacted by how you manage the soil as well.
And just bacterial and fungal ratios, Fiona, can you talk about that? What is there a specific ratio we need, and if it's not in sync, what's the problem with that?
So bacterial fungal ratios are sort of an estimate of the total bacterial population versus the total fungal population. There's a couple of ways of doing this. For example, phospholipid fatty acids is one way, or you can look at it in a molecular way as well. And it gives you a ratio. It can be informative. So the idea behind it is that bacteria tend, in general, to be more opportunistic, if you like, or where you have high nutrients disturbed systems, bacteria tend to do better. They also do better at more optimum pHs, whereas fungal communities are slower growing, but they're better able to deal with more calcitrant or more difficult to break down carbon sources, and they do better at lower pHs. There has been a lot of emphasis on this, and I suppose I'm a bit torn because it can be useful. However, what I would say is the size of any population doesn't give the full story. It really matters who those components of the population are. So imagine you're building a house and you have 20 personnel on site building the house. It looks like you have a big team to build the house, but if you have 20 electricians and nobody who will lay a block, you won't still be able to function. So I suppose it's an overview, but it doesn't give the real detail. So I would always be a little bit recalcitrant putting too much emphasis on bacterial fungal ratios, and also the change with the system. So, and change with elements like pH, and some soils would naturally be lower pH. So there's a lot of caveats, I'd say.
Yeah, Rob, I'm kind of addled even. There's so much information coming at us even here already in the first 20 minutes, 25 minutes. How do you find it at farm level trying to implement, to learn, I suppose, what's coming out and trying to implement it? Is there enough? You know, I know there's lots of information out there, but are we getting it to the farm in a correct way, I suppose?
Sure, look, Carl, you can get bamboozled. I mean, it's fascinating stuff, and I'd say Fiona could go into any depth of any topic that she even mentioned there, and we could spend an hour just on the biology alone. I think from the farmer's point of view, um, your personal preference and your personality is a big part of this. If you like it, go for it and study it. And I think over time, maybe we were information limited, but I don't think that's the case anymore. I think there's lots of information. I would think that if I go on to some of the resources Teagasc have, or some of the resources, even just YouTube, if you have an interest in something, you are not information limited anymore. I think what is maybe slightly lacking is the inspiration. I think that people take kind of decisions on changing their farming system from internal reasons, and what they do is they end up having a look at new measures based on maybe their peers and maybe based on some things that they've learned from friends of theirs. So I would say that information wise, to evolve, you need to surround yourself with interested people and like-minded people. And I think that what you can do is you can see with your own eyes, hopefully in a context similar to your own, because things have to be translated into your own situation. So if Fiona said something there that's spot on, I would say, okay, doesn't apply to my wheat, but it might apply to my grassland situation. And suddenly, like this complicated subject, it needs nuance and it needs quite a local element to it. So I think that those things are there if you can surround yourself with people to talk to about it. It doesn't have to be, it could be online, it could be any version of it. Base is one, but there's loads of them out there, and it doesn't even have to have a name. It just be a bunch of farmers to get together. And I do think what is important is to sort of break away from the tradition a little bit, because our industry, as fabulous as it is, has been sort of very, very heavily researched in the chemical aspects of soil, which is the fertilizer part of it, which is what is sold. There was money to be made out of that. So here we are now with this whole new frontier of biological agriculture. And I suppose companies aren't really saying, oh, how do we rush to this to make money? If the farmer is good at it, he doesn't have to pay anybody. He can create the environment for this biology to start working for him. So I would encourage people to get online and to start researching and start looking. And I would say that, yeah, absolutely. If you do get inspired by anything here tonight, just take it and go with it. And there's lots of places to go and to find out more.
Yeah, and you mentioned fertilizers, and we're going to get into soil chemistry in a minute. And Fiona, I might get you to give me a hand with that one. But before we get in there, Saorla, there's other things going on in the soil that you're very interested in. Maybe tell us a little bit about it.
Yeah, so I suppose I have a background in pollination ecology, and people are unbeknownst to solitary bees that live in the soil. So we have more than 60 different species in Ireland of solitary mining bees, and they require, I suppose, healthy soil in order to lay their eggs. When I say we've over 60 species, that's over 60% of the different species of bee we have in Ireland. So our numbers are changing, but we've just over 100 different bee species in Ireland, and the majority of those are solitary mining bees. We've a student actually doing some research, a Walsh scholar in Johnstown Castle, and his PhD is looking at what soil conditions can impact the occupancy of these solitary bees. So having well-drained sites is very important. But also these bees can't actually travel very far to get food. Some of them can only fly up to 200 meters. So if there's a nest in one location and there aren't flowers close by, then you won't have these bees surviving on your farm.
I know we kind of look for south-facing beescapes and stuff, and bees love temperature and that. And I can see them. We have them on the farm at home, wherever there's soil, you can see bees, particularly during the summer. But if you're on a farm or in a garden that maybe doesn't have something particularly like that the bees naturally come to, how can you create habitats in your garden or on your farm or on your land?
So again, the recent research from Colin O'Leary's PhD is showing that the bees are preferring areas where the vegetation has been removed. So just removing the top 1 to 2 centimeters of vegetation, creating this bare soil habitat. But you may not need to create this if you've got livestock on your farm and those livestock are rubbing up against the bottom of hedges. They're actually creating this habitat for you. And I say it time and time again that it's an amazing example of farming and biodiversity working together.
Super. I think we'll come back to that again because it's interesting. We kind of sometimes when we're talking about soils, we forget about the other stuff that uses as well. We look downwards too much sometimes. So it's interesting to hear that there's other things going on. Fiona, we might go to a bit of soil chemistry with Veronica
Yeah.
and David, maybe. There's plenty of questions after coming in on that as well.
There sure is. So maybe we start with David. Calcium magnesium ratios. So we had a question on whether they're important and what they should be, if they should be a certain ratio.
Yeah, no, good question, and one that comes up quite a lot in terms of the cations. Look at, I suppose, as an overview of cations in general, or nutrients in general, we need to have a balance. We need to strike a good balance. If we have too much of one and too little of another, then we're going to be short. And you know, going back to maybe our schooling or whatever, you know, if you're short in one thing, everything else falls down. So in terms of the calcium magnesium ratios, Irish soils in certain parts of the country might be calcium rich naturally. We'll say, if we think about our calcareous soils over limestones, or they might be magnesium rich. Soils in my own county here in Wexford, Carlow into Kilkenny, are typically magnesium rich. And the ratio is important to some degree, as long as there's enough of each for the crop or for the plant to grow. There is some antagonisms in terms of animal health. So if you have too much of one and not enough of another, you can run into issues with grass tetany or milk fever, depending on the time of year with grazing animals. However, the balance is more important here, and it's really important to know that the plant is the gatekeeper. So if the plant needs the nutrients, if there's enough to go around of each nutrient, it will preferentially take up those nutrients in the right amounts. However, if the ratio is totally out of whack, where you have calcium dominating and not enough magnesium, then you may run into an issue if you're short in total magnesium in that situation. The other issue that comes in here, and I'll be brief, is magnesium is a tighter element. So it will pack a lot tighter in the soil. So soils that are magnesium dominated, it's a smaller radius of element, it will pack a lot tighter. And there's a lot being made of that, making soils tighter and more compact. However, that really comes down to the management on top of the soil, be it machinery traffic or animal traffic, which Dermot may allude to in future questions.
So if you were in one of those soils, David, what would you recommend to avoid your soil hardening?
What I would recommend in that situation, so naturally the soil, it's parent material that's going to dictate overall how much is there to start off with. We can then fortify the soil. So limestone might be one thing. If we're short in calcium, or really pH being the issue and it needs to be lifted, we can look at a different type of lime. So in a magnesium rich area, you might go with calcium limestone. And in a calcium dominated area, you might go with dolomitic lime or magnesium lime. So just to readdress that balance. Other than that, I suppose there are other cations that we need to think about in there in terms of potash. Sodium is not a plant essential nutrient. However, in terms of, there's a lot of fertilizers now with sodium in, and they tend to make grass sweeter, I suppose is the phrase that's used. It's not essential for the plant, but obviously in terms of graze outs, etc., with animals. But ultimately, if we have the right balance, be it through a chemical fertilizer or be it through good use of different organic manures, we can strike that balance. That's the key.
And just one other question there before I move on to Veronica. In terms of recommendations, so most farmers might do PK lime requirement, and the questions come in, should we be looking at a wider range? So CC, cation exchange capacity is mentioned, or carbon. Are these relevant for farmers to help them manage, or what would you recommend for a farmer, or indeed a gardener? We might have some gardeners on.
100%. You know, a full balance is essential. First and foremost, I can't knock anybody that's doing a soil test to do the basics in terms of pH is probably the most important analysis that you can do. It's basically the regulator of all your nutrients. Your soil biology will respond in that. So getting your pH right and for whatever situation that is. So if it's a more diverse sward that's in an acidic area, that's fine. You mightn't want to do anything with it. If you're using fertilizer like Rob is doing, trying to grow a crop that's sensitive to acidic conditions, then lifting your pH will see you a lot of the way along. In terms of those other things, carbon really essential. We don't think about it as a nutrient, but if I give you an example of a grazing area versus an outside area that might be cut repeatedly, we're basically taking the carbon out of that area. It needs organic manure going back, and we can fortify that area with chemical fertilizer. But if we don't put labile carbon in there, it'll become stale. And I don't know whether everybody will understand that term, but stale ground is ground that's not refreshed. The soil biology has to work too hard to get its food, which is carbon. So by priming that with a little bit of carbon, we can get things back up and running again. So where we put the resources that we have on the farm is really critical to keeping soils refreshed. Rob mentioned putting organic manures into tillage ground. That would be the same analogy as the silage ground that would be cut repeatedly. You're taking a crop off. What are you giving it back to actually refortify, restart it? A little bit of more labile or more available food there for the soil biology, which can work in your favor.
Great. And so just passing on to Veronica there. Veronica, one of the questions we came in, I think, was a farmer who had a low P fixing soil, and he or she is wondering what they should do or how to manage that.
Okay. So low P fixing soils, it can be P fixation problems can be because of either a low pH of the soil. It goes back to what David talked about, how pH is a regulator, but it can also happen on high pH soils. So I suppose in the case is establishing what's going on there. So if you have a low pH, you need to address that by correcting the pH by liming. And some soils tend to drop their pH faster than others. So if you're finding that, you may want to increase the amount of times you soil sample for pH, maybe moving from every 4 years down to every 3 or even every 2. If it's a case that so by correcting the pH, you should find an improvement of the P availability in the soil. If it's a case of a high pH situation, in that situation, it's kind of harder to correct it because you can't unlime the soil to a degree. So in that case, like it's a big problem up where I'm based in the Midlands. So, and it's high tillage areas. We look at things like placing fertilizers or placing phosphorus fertilizer into the seedbed. Also the use of bioavailable phosphorus, so organic manures. The phosphorus in that can become a little more like a slow release fertilizer and not get locked up as quickly. So in both situations, the use of organic manures as a source of P might be also something that can really help.
So I guess knowing your soil and what soil you have is quite important. And
absolutely, yeah. And soil testing, and kind of goes back looking at what you have and testing your soils, looking at your soils.
Yeah, and so just one final question, then I'm going to pass back to Cathal. So if you have no P allowance, would your slurry have enough phosphorus to sustain? They don't say what their crop is, but for the year, would you, on a grassland or a tillage, would you have enough phosphorus in the slurry?
Well, if you've no P allowance, it's probably because your soil is testing at an index 4, which suggests that your phosphorus, the supply in the soil is sufficient to cover your crop needs, unless it's just you didn't test your soil and you've no P allowance because you don't have a valid soil test. But look, basically, the book values for cattle slurry, I suppose is what's being queried here, would say that an application of about 2,000 gallons to the acre would give around 13 kgs of phosphorus to the hectare. And the maintenance allowance for grass systems, depending on stocking rates and tillage systems, ranges from somewhere between 10 kgs in a 170 grass dry stock unit up to 25 in a tillage system. So basically you're getting 13 kgs and you need somewhere between, with 2,000 gallons, and you need somewhere between 10 and 25 depending on what you're growing. So it's a good start, but they're book values and they're based on a multitude of different slurries that were tested from a multitude of different storage facilities and different types of slurry systems. So I suppose the first thing I would be doing if I'm relying on it is testing it somehow. So you can send it into an accredited lab and get it tested, or we do recommend the hydrometer, especially at low dry matters. It can be quite accurate, and we do know that dry matter can be correlated. Dry matter of the slurry can be correlated to the phosphorus, to the nutrient loading.
Just when you're talking about allowances, Veronica, there is a question around, this is a tricky one for you, I don't mean to put you on the spot, but is there a chance soil fertility is suffering due to regulation and farming by dates?
Thanks, Cathal. That was very nice of you.
So it always comes up.
Look, I'll be honest with you. I've been in this kind of game for a while, and you know, a lot of people give out about regulations, but the regulations require now we soil test. That's fundamental to building fertility. They require a nutrient management plan on farm. And I'd like to think people look at them and use them. There's also regulations that mean certain groups of farmers have to employ a liming program, which is the gatekeeper, it's the master variable for soil fertility. You know, other things, the P build-up rates, the department have introduced schemes then like the soil sampling program, the liming payment. Like a lot has been done to promote soil fertility in the regulations. So, but look, soils are different. All soils are different. They behave differently. As I said, I'm based in the Midland with high pH soils that aren't quite going to work the same way as an acid mineral soil is. And when you put in a regulation, the easiest way to monitor it and you know, employ it is to make a one size fits all kind of thing. And that doesn't suit soil. But for the most part, I think, you know, the fertilization rates and all of them are based on sound science. So I like to think the regulations have done a positive for soil fertility.
Yeah, it's there, I suppose, to get food on a plate, not to go down into the river. So it's there for a reason, that calendar farmer. So it's an important one.
The calendar farming, I mean, I get this all the time. I get this, oh, this November was so mild, but you know, it's not just about soil temperatures, it's about day length, sunlight hours, and like the research from the catchments program has shown that we are losing a disproportionate amount of N and P over the winter period. And we're losing, is it somewhere, you know this better than me now, Cathal, something like 45% of N and P in a 25% of the year. So, you know, this calendar farming, it like it's there for a reason.
Yeah, it's hard enough build it, not alone lose it into our
Absolutely.
water courses. So I think we'll go on to maybe a bit on the physical soils now at this stage. We've done chemistry and we've done a bit of biology, and we'll come on to you in a second, Dermot. But just, I suppose, when we're talking about the physical makeup of soils, and people will be familiar with compaction, and Rob talked about taking out cubes of soil to assess the soil earlier on. Veronica, I know you do a lot of work in this area. Before, and this is a thing that when we're out looking at compaction, people want to know, how do I fix it straight away? And Dermot's going to tell us in a minute how to fix it. But how do you assess it first? Like, how do you know if you have compaction? Like, and then
Well,
like,
this,
how can you figure out what's caused it maybe?
well, this is where Robbie stole my thunder, like really. But as part of the Ground Truth campaign, that's one of our soil health tests, the grass vest. The grass vest is, as it says, suitable for a grass-based system. We have an alternative called the double spade method for a tillage-based system. But the first thing when you are talking about what to do with compaction is you need to start by assessing where it is in the profile. Is it surface? Is it subsurface? How severe is it? The grass vest will give you a quality score. And based on that quality score, you know if this is something that will remediate itself over time if given a chance. I mean, everyone's talking about these dry spells and these big cracks in the soil. There is a soil formation process happening by nature, wetting, cooling, heating, drying, earthworms, everything we've talked about, the activity or the addition of organic manures, all of that remediation, it can happen without pulling anything through the soil. So if it's light and in the surface, it's important to establish that. If it's deeper, it can get complicated. It's tricky. And that's where the VES has to be conducted to establish where it is, because its depth and the severity of it will dictate how you're going to proceed, really.
Dermot, this is probably where you come in when someone's in trouble and there's ponding and there's all sorts of stuff, lack of production on the farm, and they're saying to you at a discussion group or an event, tell me how to fix it quickly and under pressure. What do we do?
Yeah, well, the first thing I'd say is there isn't a quick fix, because I think the first thing you need to do is to prevent future compaction, right? So that's more or less whatever you're going to do. In some cases, you might actually be leaving it. But in case of compaction, prevention is better than cure. Okay, so compaction in this case, these cases can be from animals where maybe high stocking rates, but particularly maybe extended grazing and wetter periods might be the cause. But more typically on many farms, it's to do with machinery. It's weight, because machinery's got huge, and also the need to work at certain times. So whether that's for harvesting of crops, whether it's sowing crops, or indeed whether it's harvesting silage, getting out slurry and so on. So the approach to preventing compaction is really then around managing that traffic, whether it's animal traffic or whether it's machinery traffic, to avoid traffic in the ground when it's vulnerable. And that's usually when it's wet, if you like. So it's about managing the traffic in terms of timing, but also in tillage soils, it might be managing it in terms of how we work the headlands, for instance, of the fields. And there's scope there maybe to work headlands in slightly different ways, and even to control traffic even more further than that. So that's the managing of the traffic. But even within all of that, in terms of machinery, given the huge weight that's there, we have to be very conscious of that weight, and be conscious of how we distribute that weight on the soil. And in this area, trying to reduce individual axle loads by maybe moving, in some cases, from mounted equipment to trailed equipment, because we have a great liking for mounted equipment in Irish agriculture with smaller fields. But more particularly, it's about the wheels and tires we put under that machinery. Today, people think we have big wheels and tires beneath machines, but considering the size and the weights of those machines, we have not. So there really needs to be a proper approach to tire size and tire selection and inflation pressure, which is based around reducing the stress on soils. And that's a mixture of bigger tires, the correct ground pressure, and using new technology in tires such as VF or IF tires, which can help spread the load even further. So it's really about trying to reduce soil stress in those ways.
People love quick fixes, and I've often heard people asking you the question, there's two pieces of machinery that commonly come up, maybe go through them. One is a subsoiler and one is an aerator or the spike roller.
Yeah.
Can you talk me through the pros and cons of using them, or should we be using them at all, or is there a place for them?
Yeah, well, as I say, first is to try and prevent causing the damage. But yes, there are situations though where you may want to go in and alleviate it. But I would say even in those situations, if you're doing any alleviation action which is involving deeper tillage, you need to be able to respond to that by not damaging it shortly afterwards. So never to forget that part. But to deal with it first, I think you mentioned aeration there, or lots of farmers will call it spiking. We did some work on this back a long number of years ago, and in certain conditions they can give a yield response which comes from breaking a very, very shallow pan. But in that case, the compaction needs to be very, very shallow. There was one piece of work over in Wales, I think, which showed a dramatic improvement in performance where a spiker was used, but that had an extremely shallow compact layer, something that you might get like from sheep grazing over a wet winter. It's not going to do much for you where there's more deep-seated compaction. That would be our experience with it. Subsoilers, where you're working much deeper than that, again, best to avoid a situation that you need them. But there is no doubt that in certain situations where your soil is compacted, you may need to go down and loosen that. I would say a couple of words of warning. Number one is only to use them in extremely dry conditions, because you are looking to shatter that soil, if you like. If you use them in anything other than dry conditions, you could make the situation worse by literally just smearing the soil. You need to only go to the depths at which you have compaction. It's not a case of just throwing horsepower at it, but actually go out there with the spade. You must, as Veronica said, you have to go out and find where the problem is, if there is a problem that will respond to this, and then go out with that. And after that, you're really talking about at least a season or maybe 2 seasons of very, very gentle management on that soil to allow it reconsolidate naturally to some extent. Because when you break a pan, you're actually making the soil beneath that a little bit more vulnerable to damage. So if you go back in and do the same thing again that you did before, you could bring the compacted layer deeper in the soil. Then you have to go chase that in a subsequent year. So you're making the situation worse. So it's very much a soil management approach. I would say avoid getting the situation where you need any of those tools, if at all possible. But if you do need them, use them very, very carefully. And above all, be sure to avoid recompacting again after their use.
Olaf, I'm going to bring you back in there again. We talk about earthworms and a lot of machinery use. How do your earthworms feel?
For me there, Cathal.
Yeah.
Sorry, Fiona.
You're back. Yeah.
I'm back. Am I?
Yeah.
Yeah, Olaf, I'm going to bring you in
That's a
there.
difficult question.
Yeah.
Go on.
Yep. So tell us a bit about the earthworms and how do they feel about the heavy machinery?
I would actually like to ignore this a bit because I think we are all speaking about the individual bits, and I actually really like the health idea. Okay, now scientists, not all scientists like this, but if I look at Rob and everybody, I think there's actually some really easy message here. The health, this whole idea, we've moved on from soil fertility, soil quality, because it is holistic. It's not a chemical ratio or about density value or an earthworm count. But it's actually all of these things have to be good. And the really good news is that if you use any of these indicators and you do them good, it will actually benefit overall soil health. And I just would like to emphasize that a bit, as a sort of an overarching message, because if you think about it, there's a living it is a living system, as it says in the definition. And the good news is that, we know what we have to do and not do. So you feed the soil, you give it the carbon, you give it a vegetation cover to feed and protect it, you avoid the compaction. And of course, you do your soil tests. So if you do anything that would benefit earthworms, so, give the soil rest, have a cover, add manures, that will also benefit all of soil health. So that was a bit of an indirect answer, but I would just like to widen it out a bit.
Yeah. So it's all about management practice and doing the right thing at the right time. And Dermot, just come back to you again. We had a question around root crops. Is there kind of a challenge around maintaining soil structure and root crops, potatoes and carrots and that kind of thing?
Yeah, I think there is. Certainly different crops have different challenges, but any of the modern root crops, potatoes, carrots, where you're involved with late harvesting, where you're involved with intensive and deep tillage of the soil, where you're involved with destoning, moving the stones out of the bed area, you're making your soil more and more vulnerable. So I think it's important that you only grow those crops really on soils that are a little bit more, I suppose, resistant to damage, that aren't prone to be very wet at harvest times and periods like that. And they certainly need to be rested and minded afterwards. So yes, those crops, and particularly, say with carrot harvesting today, they're looking for carrots. The supermarkets look for carrots nearly on a daily basis. And, it's a wash carrot they're looking for. In other words, they're not going to last very long. So there's tremendous pressure on the producers to harvest possibly right through a winter period when soil conditions might be very challenging. So certainly those crops do present a big challenge.
I'm going to jump a little bit around now. Just a couple of general questions that have come in. David, I'm going to come back to you. Nitrogen, we saw the EPA brought out a report there during last week, and nitrogen is on the tip of everyone's tongue all the time at the moment and issues around it. Can you talk to us maybe about, Fiona mentioned about the dry time, and mineralization at the end of the year. And the question is, how much nitrogen is produced or fixed by soil organisms? Or is it always available?
This is one that's probably less understood out there. We reach, I suppose, for the fertilizer, for the manure or whatever to supply our nitrogen. However, the soil itself in the organic pool has tons of nitrogen. However, not all that nitrogen is available at one time. So you mentioned that, Cathal, the mineralization process is where the soil biology basically chew up the soil organic matter. They take the carbon, that's what they're after, and they release other nutrients, nitrogen included, but phosphorus and many other nutrients, trace elements, etc., in that organic matter. Typically, in an Irish context, on a mineral soil for grassland, you could get anywhere between 50 and 150 kilograms of nitrogen per annum mineralized. Now, that doesn't all happen at the one time. So while soils are waterlogged, so air is a key constituent or a key resource that the soil biology need. They need a little bit of heat. They need a non-hostile environment. So if it's very acidic, etc. So pH is important. And they need a labile source of food. So if you have some soil organic matter in there, so take a typical grassland soil that's been managed, that soil, anywhere between 100 and 150 kilograms per annum. You go back to the arable situation or the tillage soil, maybe it's in tillage for a long time. If it hasn't got manures, it could be closer to 50 or 80 kilograms in the year. And if we think about our lawn is not getting fertilizer on a regular basis, but if you weighed all those cuts and every time you go out with the lawnmower and you weighed it, you'd probably get 3 or 4 tons of dry matter off that lawn with no fertilizer. And that's all coming from mineralization, especially if it's a cut and cart kind of system where you're throwing the clippings, you're not mulching them back in, you're not feeding that back. Again, that's akin to a silage system. So we should take that into account. Some soils, if you have more soil organic matter, if it's has all the good constituents, it's getting a bit of slurry, so it has labile carbon, it has a good pH, the mineralization is going to be a lot higher. Obviously compaction as well, that air can get in there for those soil biology. That's going to have a lot higher mineralization than a soil that's heavily compacted, neglected in terms of pH, and you've given it nothing to get it started in terms of an organic manure.
Yeah, and there's another thing that comes up a lot are additives, humus and biochar and all sorts of additives that we can put on our soils to bring them back to life. And I know Fiona's mentioned our organic matter levels are actually quite good in Ireland, and if we look after our soils, do we need these kind of additives, or can we manage our way around them?
Look at again, horses for courses. There's context again, and I think Rob mentioned that we shouldn't. One soil doesn't fit all in this context. So by and large, adding more carbon to a soil that's already full of carbon is not going to help us very much. However, if we have a soil that's low in carbon, or that the labile carbon or that fresh carbon has all been used up. So if we're not putting organic manures back where we're taking off heavy crops, etc., or in that cut system where you have an outside silage block that you haven't given it any carbon back, there may be a case in those contexts for giving it carbon. Now, the carbon could be organic manure, or you could go for more expensive packaged carbon and give it a dose of that. But ultimately, that'll be a drop in the ocean. We need to actually change the system, give it back on a regular basis, and fortify that soil with that carbon in the long term. So by and large, we're in a lucky context here in where we are in the globe. So Northwest Europe, we have plenty of rainfall. We have a humid climate with temperatures that are not too high. So we have conditions where we can build carbon over time in our soils. If we go to somewhere like the Mediterranean, where it's baking hot, we don't probably grow enough productivity in terms of plant biomass to have returns going back in, and there may not be a source of organic manure around. In that context, something like a carbon source, I think you mentioned a humic acid or whatever, that's going to give you a lot more response in that context than others. So while we say in our context, some of these things don't give a response, it's not that they don't work in any context. They just don't work or are not needed in our context. So I think we need to be thinking a little bit before we put our hand in our pocket.
Yeah, and we're nearly out of time now, but I think before we come to you, Fiona, to finish up, Rob, I might bring you back in there again. You're fighting the battle on the day today, as I said earlier on, and you have very good knowledge of soil health. But there's lots of farmers out there that maybe doesn't have the same knowledge. Do you have any words of wisdom for them? What should they do? Is there something simple they can start to dabble in it and try and make improvements? It's not that scary of a topic, I suppose. How do you get into it?
I have an appalling knowledge. I have a bit of enthusiasm, and I'm around a lot of people who know what they're talking about. I suppose this is a great start, and if you're on here, this is fantastic. I guess spreading the word a little bit is quite difficult. It's something I'm interested in myself. I would suggest that we've touched on some Albright soil balancing there with the magnesium and calcium ratios. There's a book by Neil Kinsey called Hands-on Agronomy. Great start off for anybody who joins base, really good. There's a book called The Biological Farmer by Gary Zimmer. Also an excellent start if you do want to start reading. I find in general, the more you know about a subject, the more you enjoy it. So I think once you start piecing some foundational knowledge together, it starts becoming more enjoyable. And I think there's a initial, if you don't know terminology, language is a very important part of this. And I would like to talk to people about drainage and soil. Small stable aggregates is a massive start. You can make small aggregates with gear, but they're not stable. The power of roots is massively understated, I think, in the modern system. So we need to talk about roots. We need to talk about the most important element in soil, which in my opinion, Robbie Burns said this a long time ago on base, is air. And if you can have air in soil, you will get biology. And those small stable aggregates in between all those pieces is where the magic happens with the biology. So I guess to answer your question, Biofarm is a fabulous event to try and get people into soil specifically. Some of the Teagasc stuff that's coming out as well. Danu did a fantastic EIP, and that is an absolute encyclopedia if you're looking for in-depth technical information. I would say just keep asking questions and go and dig. And you're dead right, Veronica, in your assessment with your visual assessment. Smell it. Your nose will tell you an awful lot about soil, and if soil smells good, it's probably healthy. And we're generalizing an awful lot of stuff here, but with the farmer, it's very easy to go out and just start looking and poking and pooching around, and that'll inspire you to go on this journey. I hope people can, and fair play to you for putting this together. Thanks a million for the chance to be here.
Wise words, Rob. And Fiona, just before you maybe deliver a final message, there's lots of resources there on the Teagasc website. Now, Veronica, there's a very good video you did lately on actually assessing soils, and I'd encourage everybody to go onto Teagasc website to see that, because it talks you right through it. And the Ground Truth Project, it's really good resource as well, Fiona, as well, doesn't it?
Yeah, so we've a range of resources, and I suppose just to say, emphasize what Rob says, you don't need to be a specialist, you don't need to be an expert. Go out with a spade. There's a couple of simple tests that you can do, a starting point. Everybody can do something in soils, everybody can learn, you can get involved, and you can adjust your management then according to what you find. So don't be shy to ask questions. We have Soil Health Week this week, so there's events all across the country. There's some lovely podcasts coming out. There's one on AMF, came out this morning. Tune into some of those. We'd be delighted to interact with you on the Ground Truth Project. And yeah, I say just get stuck in and learn a little bit as you go. And from all the questions we didn't get to, there's lots of interest anyway, so that's really positive to see. And we'll hopefully have some other events coming forward. I know David's on the Signpost webinar this Friday coming, talking about different soils. So if we didn't get to your question, you can you can send them on to David next Friday, and he can pick up some of those questions there. But thank you very much for signing in, and thanks so much to all the panel for your time, and particularly to Elena, he's in the background, also keeping everything ticking away, and also so important in terms of the Ground Truth Project and delivering that. So thanks so much.
Unfortunately, that's all we have time for this evening. So, but just massive thank you to everybody for putting all their questions. Like Fiona said, there are a lot of questions came in. Fair play to the panel. You've got through a lot of them in really good detail as well with the time we had. So, massive thanks to our expert panel: Fiona Brennan, Rob Coleman, Olaf Schmidt, Dermot Forristal, Veronica Nyhan, Saorla Kavanagh, and David Wall. It was a really good conversation. It's a really important topic. And Rob, I think you said at the start, soil is everything. We have to start from the ground up. That's what makes everything happen. Massive thank you to Research Ireland and Department of Education for their support. And again, I'm going to double up there. Big thanks to Elena Hayes in the background, pulling all the strings and keeping the webinar, making us look good up front. So that's it. Thanks a million for joining us this evening. And I suppose if you get anything this evening, just don't forget to look after your soil's health. With that, slog of all.